Hello everyone, my name is David, and this is part 1 of my series on web programming. There's one video before this, part 0, that goes over some internet fundamentals. This video will introduce HTML and CSS, the languages used to create web pages. I'll include links to all the code examples in this video. Practice really is the key to learning, so I encourage you to open the examples and play around with the code. Don't expect to remember the information covered here without a lot of repetition. HTML is used to describe the structure of a web page. Information like where any headings are, what sections are paragraphs of text, where any headers and footers are, and much more. These types of HTML elements are called semantic because they carry information about the meaning of their content. For example, the EM tag tells clients that its content should be emphasized. This is the semantic aspect of the element. One of the most important reasons to use these semantic elements is to facilitate screen readers. I pulled this quote from the American Foundation of the Blind's website, afb.org. Screen readers are software programs that allow blind or visually impaired users to read the text that is displayed on the computer screen with a speech synthesizer or braille display. There are lots of HTML tags, and most of them are semantic. Many you can tell the meaning of by their name. For example, header, footer, and main. Nav and menu are used to designate portions of the document as a navigation bar or a menu, respectively. Other tags are more cryptic. H1 through H6 designate headers, H1 being the top level, largest heading, and H6 being the smallest. OL, UL, and LI are used for lists. There are also elements that designate figures, asides, tables, and more. The full list of around 100 semantic elements can be found on Mozilla's website. Take a look at some HTML content. These are all semantic tags. In addition to the meaning they carry, HTML elements also have default styling rules applied to them. For example, every element uses one of 3 possible display modes: inline, block, or inline block. Elements like EM and A are inline elements. Such elements don't alter the page's layout by default, but they may carry other styling information. The content of an EM element may be displayed in italics, for example. Block elements do alter the page layout by placing their contents inside a box. This might be as subtle as moving the text down to the next line, but it also allows for further styling. By default, this box spans 100% of the available horizontal space and grows only tall enough to contain its contents. If you want to center, justify, or align text and other inline content to the left or right, this is done by styling the block that contains the text. If nothing else, all the content of a web page is contained inside its body element, as will be explained further in the next video. Examples of block elements include the body element, paragraphs, headings, and divs. Div is a non-semantic block element. Its only purpose is to allow styling. It carries no inherent meaning, unlike all the semantic block elements, like header, paragraph, and aside. If a semantic element would be appropriate, it should be used instead. But there are cases in which all you want is a way to specify styling rules, without wanting to assign a semantic meaning to the content. That's where div comes in for block elements. There's also an analogous non-semantic inline element, which is called span. To specify styling rules and change how an element is displayed, you can use CSS, which stands for Cascading Style Sheets. CSS is its own language that works alongside HTML. CSS allows you control over the styling of all the elements that make up your web page. Take a look at this example, which sets the background color of all paragraph elements. This is called a rule set. The rule set starts with one or more selectors. You can use an element name as a selector, as in this example, and the rule set will be applied to all elements of that type. You can also use classes and IDs. HTML elements can be assigned a class or an ID so that it will be matched by these selectors. Classes are very flexible. It's easy to add or remove a class from an element, and you can even specify multiple classes to be applied to the same element. When writing a CSS selector, classes start with a dot. They can be specified generally or in conjunction with an element name. IDs should be used if and only if you have a CSS rule set you want to apply to exactly one element. If you assign the same ID to multiple elements on your page, your code will behave unpredictably. When writing CSS selectors, IDs start with a #. There's a hierarchy of specificity among selectors. IDs are the most specific, followed by classes and then element names. Selectors can also be combined in a couple interesting ways. I suggest checking out the MDN documentation on CSS to read more about this. There's a calculation for every selector that assigns it a specificity score, and more specific rule sets override less specific ones. I will do a later video on advanced CSS and go into this topic in more depth. All the rule sets that match a given element will be applied to it, from the most specific to the least.
Strike that. Reverse it. This way, please.
For rule sets with the same score, later rules override earlier ones. Modern browsers offer powerful developer consoles that allow you to see details about a website, including what CSS properties are applied to elements. To see this information, you can open up the developer console from a menu or by right-clicking or control-clicking on an element and selecting Inspect Element. The console packs a lot of functionality. Right now, you want to be in the first tab, Inspector or Elements depending on your browser. In this tab, you can see the HTML document along with a list of CSS rules that are applied to the various elements within it. A common task is to style text. A few useful properties for styling text are color, font size, font family, text align, and line height. Now let's return to block elements and look at some of their properties, starting with the box model. Every block element has 4 parts to it. From the inside out, they are content, padding, border, and margin. By default, div elements have no padding, border, or margin. Let's make this one's border visible. With no content, there's just a line, because the div has no height. Let's add a bit of text inside it. Now let's change its background color. And now add padding. Padding is the space between the content area and the border of the box. Now let's add a margin. Margin is space between the border and the box's true boundary. The margin property can be used for a very common and useful trick. Setting the margin left and margin right values to auto will center the div inside its parent element. You can change the width and height of the block. Note that by default, these properties apply specifically to the content area. Changing the width and height doesn't alter the layout otherwise. What if we wanted to put the divs side by side? One way would be to change the divs from using display block, the default value, to display inline block. An inline block element behaves like an image. You can set its width and height, but the box is laid out along with the text. This means that the parent element's text-align property will affect inline block elements. Say we wanted to place the two boxes on a line together with their contents centered. One way would be to use percentages for the width and margin properties. This works up to a point. With no border or padding, if the content width plus the left and right margins add up to 100% or less, the boxes should all appear on a single line. But if any border or padding is added, they will spill over to the next line. In order to get around this, it's possible to change the box sizing property from content box, the default, to border box. Now it looks like it should be working, but something's wrong. It turns out that this is kind of a sneaky problem. There are spaces being inserted between the divs. To get rid of them, all the white space between the closing div and the next opening div tags has to be removed. Now all the boxes appear on one line with their appropriate relative sizes. I hope you found this video helpful. There's plenty more to learn about HTML and CSS, and I will get into much more of it in a later video, as I've mentioned a few times. The next video in this series on web programming will introduce the document object model and JavaScript. I hope you tune in, and until then, happy coding.